What if the biggest climate engineer in Earth's history was not an animal, not a volcano, and not a machine, but a tree? Long before humans, one ancient forest began changing the air, the soil, the oceans, and even the rhythm of storms. Around 385 million years ago, during the Devonian Period, Earth was almost unrecognizable. The land was not filled with forests. Much of it was rocky, muddy, unstable, and exposed beneath a thick greenhouse atmosphere. Carbon dioxide levels were far higher than today. Heat and humidity shaped the planet. Rainfall could be violent. Rivers shifted across raw landscapes. Soil, as we know it, was still being invented. Then came Archaeopteris, not the first plant, but one of Earth's first great forest architects. It had a wooden trunk, spreading branches, fern-like leaves, and roots that reached deeper than almost anything before it. This was a breakthrough. Earlier plants hugged the ground. Archaeopteris built upward. Wood gave it strength, branches gave it reach, leaves gave it power. For the first time, plants were seriously competing for sunlight in 3 dimensions. But the real revolution was not above ground, it was below. Archaeopteris sent roots into ancient stone, cracking bedrock, gripping minerals, and turning lifeless rock into the foundation of future forests. Those roots released acids and worked with early fungi to break minerals apart. This process, called chemical weathering, pulled carbon dioxide out of the atmosphere and locked some of it into rocks, soils, rivers, and oceans. Across millions of years, expanding forests became planetary-scale carbon pumps. The sky slowly changed. Greenhouse gases declined. Earth's thermostat began turning down. The result was not instant. It was geological, but the effect was enormous. As carbon dioxide fell, the planet cooled. Ice began forming in places that had once belonged to a warmer world. Archaeopteris did not only change carbon, it changed water. Leaves pulled moisture from the ground and released it into the air. This process is called transpiration, and forests became living rain machines. As forests expanded, they recycled moisture back into the atmosphere. Local rain cycles grew stronger. Dry interiors became more habitable. Weather began to interact with life in a new, more organized way. Roots also changed rivers. Instead of loose mud washing away in chaotic floods, rooted soils held landscapes together. Riverbanks became more stable. Channels became more defined. Earth's surface was being redesigned. Meanwhile, photosynthesis was rewriting the atmosphere. Forests absorbed carbon dioxide and released oxygen. Over time, this helped create air that could support larger, more active land animals. Higher oxygen did not create giants overnight, but it helped open the door. Later, enormous insects, giant millipede-like arthropods, and larger land ecosystems would thrive in worlds shaped by forest air. But this green revolution had a darker side. Roots released nutrients into rivers. Rivers carried them to the sea. In some places, algal blooms exploded, oxygen disappeared from deep waters, and marine life suffered. Archaeopteris was not simply a tree, it was a geological force. Its forests changed rock, air, water, coastlines, rivers, and oceans. Life was no longer just living on Earth. Life was engineering Earth. When ancient forests died, not all their carbon returned to the air. In swampy, oxygen-poor environments, buried plant matter was compressed over deep time. These dead forests helped create the coal seams humans still mine today. That means some of the energy that powered the modern world began as sunlight captured by prehistoric forests. But when we burn that stored carbon, we return ancient atmosphere back into the modern sky. Today, scientists study forests, soil, weathering, and carbon capture because the Devonian already proved something astonishing. Biology can alter climate at planetary scale. Every storm system today is driven by heat, moisture, pressure, oceans, land, and atmosphere. Archaeopteris did not invent weather, but it helped transform the Earth system that modern weather depends on. So the next time you feel rain, wind, or the air in your lungs, remember this. Hundreds of millions of years ago, a forest reached into stone, touched the sky, and changed the future of the planet. The first forests were not passive, they were architects, and Earth's atmosphere still carries their signature.